Find all integers a, b, and c, for which x minus a times x minus 10 plus 1 equals x plus b times x plus c for x.
This video contains the following sections: reading the problem carefully and understanding it, developing a plan to solve it, solving the problem, thinking about it further and try to apply the approach to other problems. Near the end of the video, there's an additional question which can be solved using a similar approach to that used for solving a specific problem. If you find these helpful, please subscribe to the channel for notification of new videos by pressing the video watermark in the right-hand corner of the video player.
This isn't an equation to be solved. It's an identity. The left-hand side and the right-hand side are equal for x. Two methods are used. The two sides must be equal as polynomials with the same coefficients on each side. This gives two equations involving a, b, and c. By eliminating a, we have one equation involving b and c. Solve the equation by factorization to work out b and c. Then we can work out a from b and c. Alternatively, we can choose some values to substitute for x in the original identity. For example, let x equal 10. We have 10 plus b times 10 plus c equals 1. Solve this to work out b and c. By letting x be another value, we can work out a from b and c. Now we use the factorization method. Expand both sides of the identity. We have x squared minus a plus 10 times x plus 10a plus 1 equals x squared plus b plus c times x plus bc. We know that the coefficients for the x term on the left-hand side and that on the right-hand side must be equal. So minus a plus 10 equals b plus c. Similarly, we know that the constant term on the right-hand side and that on the left-hand side must be equal. So BC equals 10a plus 1. From equation 1, a equals minus 10 minus b minus c. Substitute equation 3 in equation 2. We have 10 times minus 10 minus b minus c plus 1 equals BC. So BC plus 10b plus 10c plus 100 equals 1. We can factorize the first two terms, BC and 10b. So we can now write b times c plus 10. We can also factorize the terms 10c and 100. So we can now write 10 times c plus 10, b plus 10 times c plus 10 equals 1, because b, c are integers, so b plus 10 equals 1, c plus 10 equals 1, or b plus 10 equals minus 1, c plus 10 equals minus 1. From equations 4, we have b equals minus 9, c equals minus 9, a equals minus 10 minus b minus c, which simplifies to 8. From equations 5, we have b equals minus 11, c equals minus 11, a equals minus 10 minus b minus c, which simplifies to 12. Now we have an alternative method where we choose some values to substitute for x in the original identity. Let x equal 10. We have 1 equals 10 plus b times 10 plus c. Let x equal 9. We have 9 minus a times minus 1 plus 1 equals 9 plus b times 9 plus c. So a equals 8 plus 9 plus b times 9 plus c. Because b, c are integers, so from equation 6, we have b plus 10 equals 1, c plus 10 equals 1, or b plus 10 equals minus 1, c plus 10 equals minus 1. From equations 8, we have b equals minus 9, c equals minus 9, a simplifies to 8. From equations 9, we have B equals minus 11, C equals minus 11, A simplifies to 12.
Think about the thought process for the previous question further and try to apply the approach to other problems.
Such as this one. Find all integers m, n, and k, which 2y plus n times y minus 8 plus 2 equals y plus n times 2y minus k for y.
You can write your answers in the comments section if you like. If you have any mathematics questions of interest, you can write these in the comments section if you like. Thank you for watching. Hope you found this video helpful. See you next time.